This is what decision trees can represent. So now that we know what they are, the next question is, how shall we learn them? Okay. Anybody want to give any suggestions, like right out of the gate, about how to learn a decision tree? Let me give you a hint, right? It's going to be a recursive algorithm because trees and recursion were made for each other, right? So the natural way to learn a decision tree probably is to do something recursive, right? So how might we go about it, right? Here's a training set, right? And what's the first thing that you want to do? Actually, let me put this another way. Suppose that I give you a training set of, say, spam, where every single email is spam, right? Then what should your decision tree be?
Find the most common,
Yeah.
most influential word.
Your decision tree should just be yes, right? All your training data is spam, so you're done. Conversely, if all your training data was not spam, you could just say no, right? And that's your decision tree, right? Why is this? I mean, this in general is not an interesting case, except that it's going to be where our recursion ends, right? If at some point I get to a data set that is all the same class, well, at that point, I can stop and say, well, this is the class, okay? What if that is not the case, right? What if there's a mix of positive and negative examples in my training set? Then what should I do? Remember, our goal is to produce something like this, right? I need to pick an attribute and then another attribute, right? So what is the first thing that I need to do is pick the root, right? So how should I pick the root?
Pick the one that's most relevant to the data?
Yeah, absolutely. So we need some kind of criterion to decide how relevant, how important, how accurate, how predictive an attribute is, okay? But actually, let us punt on that question for a moment. Let's just suppose that we have a little black box, a subroutine, that returns a score saying how good each attribute is, right? So I run each attribute to that box, and then what should I do?
Most relevant attribute?
Right, I take the attribute with the highest score, right, and I make that the root, okay? So now I have the root, it's testing on this attribute, let's say that it's Boolean, right? So now what happens once I test on this attribute? It's that some of the data goes to the right, right, and some of the data goes to the left, right? So now what do I do?
Now you do it again twice.
Exactly. Yeah, now I already have my whole algorithm, right? Now what I have is a new smaller data set, and now I just do the same thing on that data set, and that is going to pick this attribute. And on the other data set, the other child of the root, right, I'm going to, pick the best attribute for that. So every time I split, right, I get a new, set of data sets, each of which I can now find the best attribute on, as if it was the root, because it is the root of this subtree. And finally, once things are pure, I stop and I predict the most frequent class. Okay. It could happen that I run out of attributes to test in the worst case, and things are still not pure. So then what do I do in that case? Somebody actually already suggested it. Right, let's say I've run out of attributes to test, and 90% of my emails are spam, which is optimistic, and 10% of them are not. What should I do?
Return the probability?
You could return the probability, yes, indeed, we can do that. For the moment, let's just suppose that you're returning, just class predictions, then you should just return spam, right? Because if you return spam, you'll be right 90% of the time and wrong 10%, okay? And there you have it. This is our whole algorithm for learning decision trees. You can look at the details of the pseudocode later, but we've basically gone over this. Right? It's a joyfully simple algorithm. It actually goes back to the 60s. There was this guy called Buzz Hunt, who's a professor at UW. That was actually the guy who initially, him and some collaborators developed decision trees. They are cognitive psychologists. He's in the Department of Psychology here. And they were actually interested in modeling, human decision making. There's actually one example of something in machine learning and AI that comes from another field, in this case psychology. The person who really made decision trees a widespread data mining method and made them mature and whatnot was a student of Buzz Hunt called Russ Quinlan, a PhD student here at UW. So this is not widely known, but decision trees, the most widely used machine learning method, were invented at UW. We are the kings. So bear that in mind. Okay, so now let's look at the next. So any questions about the basic algorithm?
So won't this cause all the best attributes to just be
on the left nodes? Because as it recurs, it'll pick the best for the left side, and then the left side, and the left side, and the left side. And then it goes back up the tree. The rest of the tree will get the worst.
No, okay, sorry. Let me clarify that, right? So here's, look at this part of the pseudocode here, right? So first of all, if the data was pure, then we stop right there, right? If the data was not pure, then I'm going to choose the best attribute, okay, using my test of which we haven't really, figured out yet, but we have a test. And then what happens with that attribute is that I form the subset that has value true for that attribute and the subset that has value false for that attribute, right? And now the recursion happens. And the answer to your question is that I immediately recurse in two directions, and it really doesn't matter which one I do first, because the result will be the same. So what I do is I create a new node for the tree that tests this attribute, and now has as its left child a recursive call to the tree growing algorithm with the data set where the attribute was false, and has as its right child the decision tree that I get if I call the algorithm with the subset where the attribute was true. Okay? Does this answer your question?
Kind of.
Silence. Kind of? Okay. All right. If you're not clear about this, as we go on, we can come back to it. Okay? Yeah.
Are we assuming discrete queries at each node?
Yeah. So this is just the basic decision tree algorithm, the simplest thing you can imagine for Boolean attributes or discrete attributes. There's a host of issues that arise, one of which is how do we handle numeric attributes, and we're going to deal with each of them. Okay. And that's when things start to get more complicated and more interesting.
So S0 and S1 are subsets?
Is what, sorry?
Are they subsets of S? So what I'm wondering is, once you choose an attribute, so from your training set, do you actually take out some of
Yeah.
the sets?
Yeah. So let's actually look at this continuous example that we have here, right? At the root, somehow, we don't know how yet, but we decided to pick as a test, is x2 smaller than 3? Okay? And that, if you look at it, is this line here, right? So now what happens is that I divide my data set into two. There's a data set where x2 is smaller than 3, right? And now I'm going to learn a decision tree on that. In that branch, I never see the other data again. And the same thing for the part of the data set that's above the threshold. Okay? And then this just keeps going. Okay? Hey, recursion is a great thing, right? It gives you powerful results with simple algorithms, and this is a nice example of that. More questions? Okay, but of course there's still a very big question.